So I can think of all people in a state of Florida. So that'd be a population of state of Florida. Of course, if you would like to start studying all people in the state of Florida, it may be very, very complicated, simply because the population, so all people in our state, keep on changing. Some people move in, some people move out. So there is no standard population, so to say, and it'll be very, very difficult to put hands on it. And that's the reason why people select the part of population which has a special name, sample. So that's the part of population, and that's what you actually can put your hands on, and usually sample of some particular size. Good morning. N is what we dealing with in every single research in statistics. So once you're able to study your sample, then you can make inferences about entire population based on that sample. So whatever data you pulled out from that sample, you then utilize to make inferences about the population. So it turns out the data could be given in terms of numbers, so you can count, and it's called quantitative type of data. Quantitative data. And sometimes data not given with numbers, maybe with names or colors or other characteristics. So that'd be qualities or qualitative type of data. So quantitative, numbers, qualitative, not numbers. Qualitative, I think I missed some stuff here, but better be careful, write it correct. So quantitative and qualitative. And turns out that these two kinds of data split into two subcategories. So the qualitative could be either nominal or ordinal. Ordinal data is the ones that you can put in order, in a very natural order that everyone will believe. Let's say if you have students in the university, then you have either juniors, seniors, or freshmen, sophomores, and I'm sure you know how to arrange them from freshmen to the senior. So everyone will agree that the senior is probably the highest rank and the freshman is the lowest rank. So if you can put in order your data, then the data is called ordinal. But some data you cannot put in order. For example, if you have names of people, when you say, oh, I can do alphabetic order or something, yes, but it's not really something that everyone will believe in this order, because someone can say, my name is Alex, I have to be the most important, and somebody else will say, no, my name is Joe, and Joe is the more popular name than Alex, so that's more important. So when people disagree in order, it means it's not ordinal, but nominal type of data. So just names, just labels, eye colors. So you cannot really say which color is better. Some people have preference for one and some others for totally different eye color. So nominal and ordinal type of data. And then with numbers, there are also two kinds of data. One is interval, and the other is ratio. Well, ratio is something that appears most often because you can put numbers as a fraction, so you can divide, let's say, heights and say, I'm twice taller than you, or 1.5 times taller, or something else, let's say 3 times older, or 2 times younger. So times, so you have ratio type of data. So what's not ratio type of data? That be called interval. And interval example does not appear very often, but if you look at the years, let's say year 1993 and the year of 2000, for example. So if you try to put a ratio of these 2 years, I think it'd be very difficult to make any sense out of this. So we don't, we just say that from 93 to 2000, the difference is 7 years, and interval or difference is what we really care about when we have interval type of data. So first chapter gets you familiar with everything that we're gonna learn here in the class. So here's the population, here's the sample, which is a part of population. Then we collect data, it's census, so you can read it if you want to, but you don't have to. So there are various kinds of data explained in here, and the main question is, how do we collect the data? Because it turns out that data need to be collected correctly. In fact, we collect a sample, right? The part of population. And this data we're going to be, well, using for various applications. So I'm scrolling this chapter to find a very important information about ways we collect samples. And turns out the best sample that we can possibly collect is called simple random sample. So people always trying to get that type of sample collected, and I'm trying to find where they actually give its definition. Actually, we don't need it because the simple random sample is actually here, and we collect it in such a way that every element in the population has the same chance to be in the sample. What does this mean? Well, let's say you decided to study population of our college, Miami-Dade College. You go to the West Campus and collect sample of students that you meet on campus. Would that be a correct sample for entire college? Well, our college, I believe, has 9 campuses. So if you just go to one campus, there will be no chance that in your sample, there will be students from another campus. If you are here on West Campus, what about North or Kendall campus? We're not going to have any elements of those campuses at all. So this is not a simple random sample. When you say, okay, Alex, it's not for the entire MDC, but it's for MDC West. So I collected the sample for our campus only. Well, and the answer is going to be no, because if you went on campus, let's say on Monday, what about Tuesday, Thursday only students? Would you be able to find anyone in your sample for Tuesdays and Thursdays? And the answer again is no, because Tuesday, Thursday, people may come only on Tuesdays and Thursdays, and you were on Monday, so there is no way you will get every element of population with the same chance to be in your sample, because there is no chance for Tuesday, Thursday person to be in your sample, as well as for Saturday student, as well as for online student. How would you collect a sample of MDC Live students if they are not on campus, if they're someplace else? That's why collection of samples is not that simple. And what they're talking about is an ideal sample, which is called a simple random sample. To collect it, you need to have lots of authority to make students to actually respond to your request, to actually find those students, to get their information. So if you work at the admissions and records office, then yes, probably you will be able to get that type of a sample. Well, otherwise, what you get is so-called convenience sample. Convenience is the worst case scenario, but in most cases, in the real life situations, that's what we get when start our research, because you go out on street and you talk to whoever feels like answering your questions. Some people may be in a hurry. Some people you may not feel like talking to for whatever reason. And this is not going to be a good selection of elements for your sample. But it's better than nothing. And that's why people usually end up with convenience samples. So the message here is you want to always get better sample. And of course, for that matter, companies, big companies that know it, they hire either statistician to find correct samples for them, or they just contact to various sources and they purchase information from those, because that way they get a true result and not just some kind of a convenience sample. So if they base their marketing strategy on that type of sample, they might waste their funds because the result may not be correct. So our goal is to get the simple random samples with every element in it to have same chance to be present, but it's always hard, and that's good to realize. So from now on in this textbook, they will use simple random samples. So they're not going to tell you how they collected them. In fact, this author of textbook, Mr. Mario Triola, is very popular because his samples are the best, because they're actually simple random samples, as he had access to lots of data. And that's why he didn't make up some numbers by himself, but those samples actually from real life situations. So that's why this book is so popular, because it really depicts the correct picture. So here they talking about various other types of sampling. They have systematic sample. Well, that's the convenience sample that I just mentioned, the worst kind of sample. So systematic samples, that's if you have periodic, like every 50th element or something, if you do production of some type of products. So you got the systematic samples to try and so forth. So those samples are definitely better than convenience sampling. And they used, again, when you have enough power, like systematic sample, well, you need to have access to some production factory, and then you can try to get every 50th or every 1000th element or whatever you are producing. So that's good to realize that the other sampling techniques are also possible. And if you will have access to the data, then you can definitely utilize this access. Or otherwise, well, people just look at the newspapers or some other articles and try to get their information from those. So just a little introduction. I don't expect you to do any homework from chapter 1. So it just talks about the way we get all our data. So with this data, we start to put numbers down, and that's what chapter 2 is about. So we're actually going to work on chapter 2. That's the beginning of the story. And this textbook is a little bit unusual because every section, every first section of chapters, such as section 2.2, will be called as overview of entire chapter. So I guess there are no exercises in this section 2.1. You can scroll down a little bit and see that it's just a few paragraphs of the story, and then we don't really do much here, but start with section 2.2. Same will be true for chapter 3, section 3.1, or section 4.1 or 5.1. They all the same, they all called overview. So we don't really worry much about those sections because there is no information in those. Well, the second section of chapter 2, that's actually where this whole story starts, is called with a very interesting name. There are two statistical words. First of them is frequency, and the second is distribution. So what does that mean? Well, distribution is a table. So here's the example of distribution. It's a table 2.2 that contains the data, and the point of word distribution means that it has to have a full picture of entire sample. So it doesn't show you just a part of sample and the other part is missing. You need to put all data in a table so you have 100% of your data, not just a half of it or 90%. You want to have the whole thing. So then it's called distribution. So that's the idea of distribution. So we always want to see the whole picture. And those distributions may have such thing as a frequency in them. So what does that really mean? And I guess I better get an example so you will get a clear picture what this means and how we actually construct these tables. And for that matter, I need to find a sample. So I will construct the table like we see here, 2.4, 2.5. So for this, I need to find the set of data. So I'm scrolling down to hit eventually a bunch of numbers, which is called sample here. So where are the samples? Here it is. You can see that in 34, we have a bunch of data. Actually, there are two groups of data. So I can take one of them. So there is a first group of data here that deals with ages of the actors. So in order to get this table called distribution, I need to know the smallest and the largest ages of those actors. And when I consider these ages, the smallest I see here, please help and see if that's 32. No, there is 31 here. Looks like 31, thank you. 31 is the smallest. And then I need to get the largest here. And looks like it's 76. I hope that's right. 76, thank you. Okay, so we have the smallest and the largest. So I can find so-called range of this particular sample. And the range will be the difference between the largest and the smallest elements in my sample. So we see that it ranges from 76 to 31, and this is indeed equal to 45. Perfect, thank you, that's great. So our width of this little interval is equal to 45. So in order to produce the table, I need to break my sample into classes. So I need to break this into usually 4 classes. So this way I will get so-called width of each class. And in order to get the width of each class, Well, I'll divide my range by number 4 and produce the class width. So if I divide 45 range by 4 classes, I will get a little bit more than 10, right? I will get something like 11 and a quarter. One can say, Alex, how do you know this? It's 11 and a quarter. Well, I don't have to guess anything. I can just use a calculator here. I can just type in the search scientific calculator. I start typing scientific in the calculator word automatically appears because that's very popular search. And the first selection here, scientific calculator, is what I'm going to utilize for this class. So I'd like to share this link with you so you can also bookmark it for yourself so you can always get to it. If you have your own calculator that you like to use, well, you can use it. It's fine with me, as long as you use it correctly. So I put in the chat, in the Zoom chat, this link to the scientific calculator that I found. And in it, I can divide 45 by 4. And the nice part of this calculator, as you can see, these fractions actually appear the way they are supposed to be. So we don't have any slashes or anything. So when we calculate more complicated looking expressions in the future, well, you will see how convenient this calculator is. I know you're probably used to some other calculator. Again, you can use it, but I will do in class demonstrations with this one. So maybe eventually you will see that this is a really good calculator, and it's absolutely free. So it's another thing that you don't have to purchase for this class, the calculator, same as a textbook. So I can always share this link with you. So anyways, we just double check that the width of each class is 11 and a quarter. And what people usually do with this is they round it to the nearest whole number because they want to make it look nicer. So 11 will be the width of every single one of my 4 classes. When I say it's 11 and a quarter, Alex, yes, but if I start to produce those class boundaries, then if I add 11 to 31, I get 42. And that'd be a nicer number rather than if I add 11 and a quarter, so it'll be like 42.25. It's not going to look very nice on the picture. And well, that might confuse some people that you will try to explain what is that you're dealing with. So I'll keep on adding 11 to produce the next class. So it'll be 42 and 11 is 53, and add another 11, I will get 64. When I say, well, you add another 11, you get 75. Well, I guess one of my classes may be a little bit wider, and usually first or last class being wider or a little narrower is fine, because those first and last classes generally do not have many elements. So I'm going to try to produce that table. So I'm going to get the starting points of classes that we have here as 31, 42, and etc. There is also 53 and 64, right? So here are my 4 starting points. Now I need to put the ending points. And what's important is to make sure that these classes do not intersect. They should not touch one another. In other words, my last class ends at 76. Should be careful with this. And then the previous class needs to end at 63 because we started at 64 the last class, so they should not touch one another. So where should I end the second class? Well, 52, because the next class will go with 53. And analogously, very first class should end at 41. So I just produced the boundaries for my classes and time to look at the sample. So I go back to my textbook here and check what we have for the sample and actually see how many elements I have in each class. So first class goes up to 41. So let's see how many elements I have here. 3, 4, 5, 6, 7, looks like a lot. 8, 9, 10, 11. And then next row, we have 12, 41, right? 13, 14, 15. That's a lot of elements. Please double check. I think I forgot 40, right? So there are 16 elements. So looks like with 16 elements that I have here, the so 31 through 41, right? Because the last one I put 4 classes, right? Oh, you say I missed 36. Oh yeah, thank you. So that's 17 elements. Thank you. See, I appreciate you double checking that because it's so easy to get confused. Yeah, so it'll be 17 elements then. All right, so 17 elements will be in my first class. And here's the name for this number. It's called frequency. So it shows how frequent the class elements are and frequency distribution is being produced. Frequency. So just number of elements in the class. What about next class that goes up to 52? Let's see. 1, 2, and here's 3. Then we go 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Also, there are lots of elements in the next class. So it looks like I found 13 of them. Let's see, did I miss anything at this time? Looks like not. Okay, that feels good. So now I go to the third class up to 63. Let me see what elements will be in it. So I can just take those and cross like that. 1, 2, 3, 4, 5, 6, 7, 8, and that's it. Okay, 8 elements here. So what's left for the last class? Looks like there is only one number, 76. The one that is underlined is left for the next class. And of course, the legitimate question always is, Alex, is this right? So how can I double check that I didn't miss any elements or if I didn't count something twice? And turns out there is a way for this by actually looking at the total number of elements in this sample, and looks like it'll be 12 times 3, 36, and 3 is 39. So it turns out that total here should be 39. And when I add all of my frequencies found together, I'll get 17 and 13 is 30, 8 and 1 is 9. So it's exactly 39. That's exactly what we have for sample size. So that's the way to check if we did it right. And if not, well, then we just want to redo the whole thing again. So that's not much fun. So with your help, looks like we did it right. So when you say, Alex, why do you need that? Well, there is a tremendous use of this process for the applications. So let's say you're trying to convince a bank to give you a loan. So you produce the business plan, how you're going to spend it, and you give them your study results. You say, I'm going to sell something to the actors, and they look at this number of actors that I considered. That's my data. Do you see that the most popular elements, ages of actors are below 42? And because it's below 42, and the bankers say, how do you know this? Look at the bunch of data. I don't see it. It's just a mess here. How can I know that this is below 42? Well, if you have a frequency distribution for them, you will say, look at this. There are 17, most of the actors aged below 42. Well, and that will convince them, right? And even better, you will make a picture, so they will get very happy and give you that loan right away. So what people do is they have this so-called bar graph produced. So they're going to get a bunch of bars here. And the first bar should be the highest with a height of 17. So to make the graph look nice, I find the largest from the frequencies and put it on the top. And then corresponding to this 17, I will have my first bar produced that looks like that. One say, Alex, better, nicer. Okay. So next bar will be of the height of 13. So it's a little bit less than 17, maybe someplace here, 13. So we have a second bar next to the first. Then 8. Well, 8 is like a half of 17 because 8 times 2 is 16. So it's somewhere here. And I get another bar. So we're producing so-called bar graph. So the very last bar is of the height 1. So this be the bar with pretty much no height at all. So with this kind of explanation, one can definitely clearly see what is going on, and everyone will agree that indeed the most popular class is the very first one, and next popular is the second class. So technically, if you target actors aged below 50 or something, well, then you will get the most of population of all the actors covered by whatever you're trying to sell them. And this type of service will definitely deserve probably some loan from the bank. And well, one will be very happy because the business plan will go through. And it's not very hard to create. It takes what, like 15 minutes of preparation, and you get yourself a nice looking graph. So it is very useful for real life situations. And you will see that this class is indeed much more useful than other classes in mathematics, because we are going to see how we can really take advantage of statistics in real life. Another very popular picture, besides drawing a bunch of bars, as you can see, I just opened the page and it has bars on it. I'm sure you're familiar already with this stuff. Is so-called pie chart. By the way, the bar graph has a special name in statistics. It's called histogram. Histogram. Well, if you call it as a bar graph, I will understand. So it's fine with me. I okay with you calling it any way you like. But when you read the textbook, if you do that, then you will encounter word histogram. So it's good to know what this means. So now I'm going to try to produce a picture of that circle cut into little pieces, or like little slices, and that's called a pie chart. So I want to produce pie chart by using so-called relative frequencies. So I want to divide each frequencies produced by total number of elements here, which is 39. So the way to go is put 17 divided by 39. For the next class, I have 13. Okay, so I will divide that 13 by 39 and etc. So 8 over 39 is for next class. And for the very last class, I divide number 1 by 39, like that. So here's our relative frequencies, and I want to actually get those because they will give me percentages here. So if I try to get this calculated, I just want to, well, use a calculator, right? So let us see here. Dividing 17 like that by 39. So I should be careful. Enter, make sure you entered everything the way you need it. And I can round this to nearest percent. So please notice that the digit that follows my number 3 is 5, which means that I have to write 44 approximately, since the following digit is 5 or larger. The rule says you move to the next, so you round up, so you get that 44% approximately for the first slice. And then you continue with the next one. So you divide 13 by 39 and etc. The next you divide 8 by this 39. And then finally, number 1, you divide also by 39. So once you divided these, then you can see how you can round it. So this will be 33, there will be 21, right? Because again, 5 follows, so let me write it down. It's 33, and that's 21%, right? 0.21. And the very last one is going to be 0.3, right? Because again, 5 follows, so I put a 3% in here, just like that. So my percentages should give me the whole thing or 100%. So let me check this out. 4 and 3 and 3 is 10 and 1 is 11. So I carry 1. And then add 1 with 4, 5. And 3 and 2 is another 5, so it's 10. I say, Alex, you didn't get 100%, you got 101%. Yes, I did not get 100%. Well, actually, it's okay because you can get off by 1%. It could be 99 because you rounded them. So if you put the entire decimals the way they are, you would get the 100%. But since I rounded in 3 places and I increased all 3 of them a little bit, so I increased the whole thing a little bit, and turns out 100% is increased by, well, such a way so it's extra 1%, and it's okay. So you don't want to produce 80% or 150%. That's way too far. But if you get like little extra, that's okay. The reason is your goal here be to get a pie chart drawn, and that's all we really care about here. So 44%. Please notice that a half of pi is 50. So 44 will be a little bit less. So you can say that here's my first slice of a pie. So it'll look like a class from 31 through 41, right? So that's my first class. The next slice is 33%. That's like a third of a pie. So that's another big slice. So it's a little less than the one I have here, but quite large. And again, it's 42 through 52 ages. So I'm trying to do my best to get it proportional, one with respect to the other, and continue with 8. So there'll be pretty much everything, because the very last one is only 1%. So it'll be a very tiny little slice. And previous is 53 through 63 here. So I put it like that. 53 goes through 63. And finally, the very last one, it's 64 through 76. And we're done. So it looks like now you can also present the data, the same data, but with slices. And if you wish to do this, you can go ahead. Well, usually bar graph is good enough, but you can also get a pie chart. Sometimes it is very useful. So going back to the textbook, I will tell you that I started to talk about chapter 2 today. And I would like to take a look at the pictures here. Please notice there are various ways to present data. So instead of pie chart, sometimes they put so-called Pareto chart. That's the name of this chart. So instead of largest piece of pie, they would produce the longest slice. And then for the very little one, like 1%, you may not even see it because it'll be very short. Like here, it's like for June, there's a shortest piece. Well, I don't think we ever utilize it. It's pretty rare. So my point is that our goal here is not to go through every single little detail of what you see in the textbook. We'll show just what's really needed for this class. So bar graph and the pie chart, as you can see right now on page 51, is something that is very popular. So we should definitely be aware. Next time I will show you this so-called stem and leaf plot, or people say stem plot of data. I guess today we're not gonna do this, because today I was planning to show you how we do homework from this textbook. So very first section of chapter 2 is 2.2. Remember, 2.1 is not present, has some of the exercises. And what you want to do is, well, just a few exercises here in this chapter. In fact, let me show you how I could do exercise number 1 here. And maybe another one here. So exercise 1, what I can do is find the sample size n. How many elements are there in the first sample? Well, all I have to do is add all of the frequencies together. Remember, just like I did here on the left side, on the bottom, the 39 was a total if I added all of these frequencies. So let me see what be the sum of these frequencies here. 5 and 7 is 12, and 2 and 5 is another 7. So it'll be 19 and 1, 20. So I put 0 and carry 2. And then 2 with 2 ones is 40. And that's it. Let me try another one. Like, how about exercise number 4? Can I find the sample size here? Well, looks like the same thing. I want to add all of these frequencies together, right? And yeah, basic skills. At the end of the section, you should do problems from the basic skills. Exactly. It's again 40. Oh, yeah, it's 5 and 5, 10, and 4 ones, that's another 40. Okay, so I guess that's pretty much all you need to do here. Also, notice that there are some exercises here that ask you to use data set 26 in Appendix B. So that's something that we don't have in this textbook. So skip it. So there'll be exercises that have this little symbol that says use data set, whatever. Well, this textbook, we didn't really purchase it, and it doesn't have those appendices. So you don't need to worry about this. So I would say you can stop at this stage with this section for your homework. In fact, I already did problem 1, so maybe you do problem 3, and that should be good enough. So how many you do? If you do a couple of problems from every section that I cover in class, that'd be enough. So just 2 problems will be good enough. I just started, so we'll continue next time with this, and little by little you will get used to it. And I will, of course, always remind you of this. So we can do just problem 3 for homework. And I'd like you to do 1 problem for a little quiz for today, which means that, first of all, you don't want to hurry, because you want to put your answer only to me, only to Alex. So how you put the answer? Well, you need to open the Zoom chat. That's where I put the textbook. And when you open it, you will see on the bottom the blue rectangle that says everyone. So you click on the arrow that points down and select only my name. Select Alex. Notice there's only one Alex here in the Zoom chat. So you should send me the answer to exercise set number 2 for the sample size. So can you please let me know the sample size, or how many elements will be in this sample in exercise 2? Don't hurry, just take your time. Make sure you put the answer in the Zoom chat. And well, that's all you need to do for today. So I'm gonna stop to record this.